These are the 7.5 part 1 video notes, and we're talking about double angle and half angle formulas here. So this is going to be very similar to the sum and difference formulas, and when we do these sum and difference formulas, we are talking about how we're kind of taking the angles which we know some facts about, or we know what the angle's basis is, and then we're going to break it up and use that and kind of plug them into some formulas. So let's look at the double angle formulas. Now the first thing that you're going to notice is that you have three formulas for cosine. All three of these work, so it kind of depends on the situation that you might want to use them. And I'll kind of explain that in the next slide of why you might want to use one situation versus another in another situation. And that just kind of varies. I would say when you get to AP Calculus, when you're going to be expected to have these memorized, just kind of known off the top of your head, it's actually going to serve you better just to choose the one that you like the best, the one that you think might be the most applicable, and just have that memorized ready to go, as opposed to memorizing all three and knowing which scenarios you use them in. But right now, while you have the notes in front of you, while you have these formulas in front of you, just go ahead and know which formula you're going to use. Use them based on the scenario, and don't make more work for yourself just because you want to work by memory right now. Now, the proofs for all of these are kind of complicated. They use the unit circle. They're not impossible to understand, but to go over the proofs of why these work, it would take a decent amount of chunk of time from these notes, and it's not really necessary to understanding what's going to go on. So if you need the proof for these, they are in the book. Also, you could just type in proof of the double angle formulas and the half angle formulas on YouTube, and you would probably find 100+ videos that explain the theory behind this and why it works. But again, that's not fully necessary. That's something that you can do on your own. For right now, we're just going to practice the application. So let's look at this, an example. If sine of theta is equal to 3/5 and we're in quadrant 2, find the sine of 2 times theta. Here I don't even have to concern myself of what sine is going to end up being because the math is just going to work out for me. So the sine of 2 times theta here, in this case, we're looking at 2 times the sine of theta times the cosine of theta. So that means I need to know the cosine of theta. I've set up to give you a pretty easy triangle here. We'll set up my quadrant. This is in quadrant 2. Sine of theta is 3/5, so we know our opposite's 3, we know our hypotenuse is 5. This is a 3, 4, 5 triangle, so now I know my adjacent side is -4, so that means my cosine of theta in this case is -4/5. So the sine of 2 times theta is going to be equal to 2 times the sine of theta, which is 3/5, times the cosine of theta, which is -4/5. Is going to be equal to 2 times -12/25, which is going to be equal to -24/25. I'm going to do some quick things in my head to work this out. So one thing that you'll note is that if this theta falls in quadrant 2 somewhere, so that means this theta is falling somewhere between 90 degrees and 180 degrees. If we multiply this by 2, that means that this theta is now falling somewhere between 180 degrees and 360 degrees, which means that sine has to be negative because this is talking about quadrant 3 to quadrant 4, where sine is always negative. So that tells me, okay, this makes sense. It's falling somewhere between 2 of the quadrants where sine's always negative. I have this really, really negative sine value here. Yeah, it's 24/25. It's close to 1, which is a little bit bizarre, but at the same time, the one little thing I can do to check myself here does work out, so I'm happy that it does work out. In this case, that means cosine could be negative or positive, depending on what that angle is. So I'm going to go through and cosine of 2 theta. Now, here's an example of why it might be good to use the different formulas. Let's say that I didn't go through and solve that. Let's say that sine 2 theta wasn't even the first question. All I wanted you to know was what the cosine of 2 theta was. Well, in this case, it's going to make the most sense to just go up to the second formula that we have here of 1 minus 2 times sine squared theta. And I could type in that this is 1 minus 2 times that 4 or 3 over 5 squared. We get 1 minus 2 times 9 over 25, 1 minus 18 over 25, and then you quickly find that this is 7 over 25. So there you go, that's what the cosine of 2 theta is. Now again, we did go through and we found that we had a quadrant 2 angle with an opposite side of 3 and an adjacent side of -4, so that meant our cosine was -4/5. So I could also plug this into the other one of the cosine squared minus the sine squared. And I could plug in -4 over 5 squared minus 3 over 5 squared. You get 16 over 25 minus 9 over 25. And that's 7 over 25. And then just for fun, we could also do 2 times cosine squared of theta minus 1. That's 2 times -4 over 5 squared minus 1. That's 2 times 16 over 25 minus 25 over 25. That's 32 over 25 minus 25 over 25. So that's 7 over 25. So again, I've got 3 different ways of getting there. All 3 of them give me 7 over 25, which should hopefully help prove that all 3 of these formulas work, and this isn't just something we pulled out of thin air here. This is solid mathematics. So that's just what there is to it. It kind of depends on the scenario. So again, from the get-go, if all you had was sine, you could plug it in. If all you had was cosine, you could work with it. If you had sine and cosine, you could work with it. It really varies situation to situation on why you would use one formula versus the other. But again, my advice is maybe memorize one of them for when you need to have them memorized next year. So that way you're not trying to figure out, oh, I have just sine. What's that formula for just sine? Go through, figure out sine and cosine, plug it in, etc. Use the formula you want to use, and that's going to be a little bit easier for you at the end of the day. We've got half angle formulas here. Now, notice that all of these half angle formulas have a positive, negative. We're going to have to do a little bit more thinking to figure out which quadrant these things lie in, and I'm going to give you that example. I'm going to show you how we figure out which quadrant these lie in. It takes a little bit of time, takes a few seconds to figure out, but nothing too difficult here. Other thing to note, tangent has 3 different formulas here. So again, it's kind of like the cosine of the double angle formulas. We've got 3 formulas for tangent. And again, it's going to vary situation to situation on when you'd use it. Whenever you have sine and cosine, I'd just go ahead and do the sine and cosine. Saves yourself some time. Makes you not have to think about the quadrants as much. You can see here with these top 2, we have to think about that positive, negative. With this bottom one, we don't have to think about that positive, negative. So it really kind of depends on how much you're willing to think about the quadrants, and if you want to think about the quadrants versus just plugging in some numbers and getting an answer. Also, if you have the sine or cosine. So here, sine of 15, we have no clue what the sine of 15 degrees is. This is not something that we've worked with before. That's not a unit circle angle, but I'm going to start thinking 15 degrees. How does that relate to the unit circle? A couple different ways we could do this. Again, we could use that sum and difference formula. We could say that it's the sine of 45 minus 30, and we could plug it into that sum and difference formula. Or we could say that this is the sine of 30 degrees over 2. Now again, we're going to know that this ends up in quadrant 1 because it's 15 degrees. So that means we know that it's a positive answer here. And I'm going to just plug this in to that half angle formula. It's going to be a positive value because we're in quadrant 1. So this is 1 minus the sine of cosine of 30 degrees, which is root 3 over 2. And then this is all over 2. So this becomes the square root of 1, or 2 minus the square root of 3 over 2, all over 2, which becomes the square root of 2 minus the square root of 3 over 2 times 1/2, which is the square root of 2 minus the square root of 3 over 4, which is equal to the square root of 2 minus the square root of 3 all over 2. And we're going to leave it here. Now, this is a really, really ugly answer. I don't like it a lot. I don't like the way this looks a lot, but this is how far we can simplify. I'm not going to plug this into my calculator. We're not going to put this in on our calculator. We don't have rules for simplification at this point, and we leave it as is. It's not the prettiest looking thing, something that's very bizarre and something we haven't seen before, but this is the most correct answer we can get. It's the most exact answer we have. Cosine of negative 15 degrees here, we can look and we can say to ourselves, okay, cosine of negative 15, first of all, this is going to just be equal to the cosine of positive 15. We can use those even odd formulas to go ahead and say that this is the exact same thing as the cosine of positive 15, which means that this is the cosine of 30 over 2, which means that this is the square root of 1 plus the cosine of 30, which is the square root of 3 over 2, all over 2. And then I'm going to go ahead and do all that simplification again. So that's 2 plus the square root of 3 all over 2 over 2, which is the square root of 2 plus the square root of 3 over 2 times 1/2, which is the square root of 2 plus the square root of 3 over 4, which is equal to the square root of 2 plus the square root of 3 all over 2. And again, this is the most simplified we can get. We don't have a square root in the denominator, so we don't have to rationalize. The numerator does look really ugly, but again, this is the most exact answer we get. We don't have those simplification rules for the top, so we leave it as is and we call this good. We're going to do that for all of the angles that fall in the unit circle, things like that. It's going to help to pay attention to what your end goal is on an angle here, because you're going to want to know which quadrant does this fall in. You still have to pay attention to those signs, but it's a little bit easier when you have that. This example here, given that the cosine of theta is negative 3/5 and falls between 180 and 270, find the tangent of alpha over 2. This is where it gets a little bit difficult here, because what I have to consider is that if alpha is falling between 180 degrees and 270 degrees, this is a quadrant 3 angle, which means that we actually have to look at the fact that if you divide this by 2, that means that alpha over 2 is falling between 90 degrees and 135 degrees. So this is an even smaller window than a full quadrant, but what we do know is that this has to be quadrant 2. And since it has to be quadrant 2, what that means is that the tangent of alpha over 2 is going to be a negative value. Now, the tangent of alpha is a positive value because alpha is falling in quadrant 3 up here. But I'm going through and I'm dividing all the angles it could fall between by 2 to realize, okay, that means that alpha over 2 has to fall between these. It's only got this 45-degree range that it could fall in. That 45-degree range all falls in quadrant 2. So this means that this value here is going to be negative. So that means to figure this out, I've got the cosine of theta. So I'm actually going to use this top formula up here, which I'll re-highlight. I'm using this formula because I have the cosine and just the cosine. I'm not going to take the time to figure out the sine. I'm going to go through and say, all right, this is going to be the negative square root of 1 minus, in this case, the cosine of theta, which is negative 3/5, over 1 plus the cosine of theta. And then I'm just going to do a bunch of simplification here. So this is the negative square root of 5 over 5 plus 3 over 5 over 5 over 5 minus 3 over 5. Negative square root of 8 over 5 over 2 over 5. Negative square root of 8 over 5 times 5 over 2. Negative square root of 8 over 2. Negative square root of 4. This is equal to negative 2. So the tangent of alpha over 2 is negative over 2. And again, I had to figure out which quadrant alpha was actually going to end up in. That was the most difficult part. You could also go through, you could realize that you're talking about a quadrant 3 angle here. Again, I'm giving you nice 3, 4, 5 triangles. So 5, -3 is your adjacent, which means that your opposite would have to be -4. And you could plug it in to this one of these up here. Let's go with the fact that we would have the sine of theta -4 over 5 all over the 1 plus the cosine of alpha. So that's 1 plus -3 over 5, -4 over 5, all over 5 over 5 minus 3 over 5, -4 over 5, over 2 over 5, -4 over 5 times 5 over 2. Those cross out, -4 over 2, and that's equal to -2. So again, we can see that I didn't even need to, at that point, think about what quadrant I was in. That makes a little bit easier. So again, either way with these tangents, with these half angle formulas, you have to do a little bit of thinking, a little bit of work. The tangent, nicely though, if you want to go through and figure out your sine, which you've been doing a lot of, you've been doing this since chapter 6, so that might be a little bit more straightforward. It's going to give you the answer without having to think about what quadrant it falls in. If you just want to work with the cosine when you just have the cosine, you do have to think about what quadrant it falls in. But again, that's just going through and dividing your range by 2 to figure out, okay, what quadrant doesn't have to fall in if I'm dividing my range of my original angle by 2. Here's your homework assignment for tonight. Obviously, not super long, a few problems just to get in the groove, practice this a little bit. If you have any questions or concerns, please reach out sooner rather than later, and have a great night.